One of the hardest things that people kind of come up against is finding an effective way to work well with Cassandra. Cassandra solves a lot of issues from a performance and an operations point of view when it comes to dealing with large volumes of data. But it can be a little bit of a mind flip when it comes to working with its data model, working with it locally, particularly given that it's a database that's designed to be distributed, and you need to be able to test your code in a way that covers different use cases, that covers different scenarios when you're connecting to a cluster that's more than just say one node. So what we'll do is in this webinar we'll cover off how to set up a local Cassandra environment. This is locally on your laptop. How to run multiple versions of Cassandra. Cassandra is a very fast-moving project, particularly the open source project. You tend to see major releases every 6 months. If you actually look at the developers list, they're actually looking at moving to a much more aggressive release timeframe that follows a bit of a TikTok approach, very similar to the way that Intel releases their CPUs. So, with the idea that brings a little bit more stability, but it also means that new features get integrated into the main version of Cassandra a little bit quicker. Plus, on top of that, how do we also work with Cassandra in terms of creating a reliable test environment? How do we integrate it into our unit tests? How do we, integrate it into our smoke tests? How do we, work it into the larger kind of staging environments that we all run? And then last but not least, I'll cover off a number of dev tools. I certainly won't cover all of them that are available. That we find, I guess, that Instaclustr is kind of the best and the easiest to help new users of Cassandra get up and running. So the challenge of making all this work is how do we essentially do this? How do we work with it on a daily basis as developers so that Cassandra's not getting in the way, and it's just another part of our toolkit that we use to build all the apps. So what we need is we need a way of working with Cassandra in a way that it's simple, it's fast, and the workflow is somewhat logical and not too onerous. We also want the environment to kind of be as close as possible to production, but without being painful to use. And then the last kind of challenge is actually understanding what's going on under the hood and how the choices we make in when we're writing code, when we're developing. How that kind of impacts Cassandra and how it works within Cassandra. And of course, making sure that, things don't blow up, when we deploy and push into production. So at each stage of a developer's workflow, you've got varying levels of interaction, right? And what I mean by interaction is how do we as developers, what's our workflow like? So, normally what we'll do is when we, on the day-to-day, tasks that we perform, we're going to be writing code, we're going to be testing it, and, there's also a fair amount of research that goes into it. So let's first address the idea of writing code. It's kind of that, write some code, compile, does it work, does it make sense, is it done in the best way that we can do it? And then once we've finished the unit of work, it's, well, does it work with everything else as a larger system? So at each stage of these tasks that we do during our days, do we have enough information to make what we're doing work if it actually doesn't? So does the information, of the test that we're writing, is it helpful? Is it useful? And can we essentially be effective developers with the tools that we're using? So working with Cassandra requires us to essentially have a running copy of Cassandra locally on our laptops or our development workstations in order to support this, code, compile, run workflow. So what we want to do is we want to start from the basics, and what I'll quickly do is I'll run through a quick demonstration of downloading Cassandra, extracting it from a tarball, the compressed archive and running it locally so that we can work with it locally on our machines. So just bear with me while I share. There we go. So what we have here is I have previously downloaded a number of versions of Cassandra. We can see here I've got the latest version of the 2.0 branch, the latest version of the 2.1 branch, and the most recent 2.2 release candidates. So I've just downloaded these from cassandra.apache.org. There's a number of distros out there. You can get packages for Ubuntu, you can get packages for Red Hat, you can just get the plain tarball. The tarball will work on any Linux, Mac OS, and Windows machine as well, as long as you've got a fairly recent version of Java. So if we have a look here, current version of Java that I'm running is 1.8. I believe Cassandra, the 2.0 branch, the recommendation, at least previously, used to be 1.7, but as we all know, the 1.7 is currently approaching end of life, so at the moment we're just running 1.8. So let's jump into the directory, and we'll start off with 2.0. When it comes to running Cassandra locally, depending on what version you use, there's a number of different things that you have to do in order to get it working locally first. So with Cassandra, the Cassandra 2.0 branch, in order to get it up and running locally on your machine, you will need to have a look at the Cassandra YAML file, as there's a few hard-coded defaults that usually won't work with running it from a local machine straight out of the box. And the main one is the directory in which Cassandra will store its data files. So if you're running it locally, my guess is that you actually don't want Cassandra writing directly to your varlib or the global varlib directory within your workstation, simply from either a permissions point of view, but sometimes it's also a good idea to keep all the files that Cassandra will create, so the data directory, the commit log directory, the caches directory, and also just the general log directory, all kind of contained within the same place. So what we're actually going to do is we're going to make Cassandra run from the working directory. So what we're going to do is we're going to put a / in front of it. So I'm going to jump through here. For those who are wondering, I'm currently using Vim and just searching through it. Unfortunately, highlighting is not, or syntax highlighting for YAML files is not working on my copy of Vim today, so that's pretty cool. Alrighty, so the main place you'll need to do it, there's 3 places in the YAML file. It is the data directory, the commit log directory, and the caches directory. You'll need to update those. Once you've done that, you'll probably also want to update the log properties file, as it will also try to write the log to the /var/log directory. As you can see here, I have already modified the path, so it should just do it from the working directory of where I run Cassandra from. Cool, alrighty, so let's see what it actually looks like. The way that I like to run Cassandra locally from a tarball installation is I like to run it in the foreground. This means that logging is automatically pushed straight to the console. Well, it's done via that log4j properties file anyway. But the main benefit is that I can see, I've already got a copy of Cassandra running. So let's just first kill that. Cool. Alrighty, there we go. So what we've just done is we've launched Cassandra in the foreground of this terminal session. As you can see here, we'll scroll up a little bit. It's initialized a new data directory. It's created some new tokens for itself, and created all the relevant key spaces in the system directory, and we are now good to go. So what I'm going to do is I'm going to split my window in half here, and we are going to go back to the directory that we were working in, 2.0.16. And from here, we can now jump straight into the cluster. So we can have a look at what's going on. Let's go have a look at a system table. System.peers. Nothing in there because we're the only node. So what we've just done is we've created a single node cluster, and it's kind of all ready to go. Now let me jump back to the presentation. So that's the quickest way. Well, that's probably one of the simplest way that we can use to kind of get going with Cassandra. We can just download a tarball and off we go. But it does have a little bit of overhead. We do have to manually work with the tarballs. We do have to. What if we want to run multiple nodes, multiple data centers, that kind of thing. All of a sudden, it becomes a little bit complicated. I was actually going to show you guys how to work with multiple nodes using just an extracted tarball, but when I actually ran through this previously, it ended up taking me about 10 minutes to run through it, because for each node that you want to run, you've got to have, you've got to duplicate your YAML file, you've got to then have different data directories, different commit log directories, you've then got to bind it to different interfaces, so you've got to work out how to do that, and it becomes a lot more complicated. So surely there's an easier way to do this. See, way too hard. The solution to this is a project called the Cassandra Cluster Manager, or CCM. CCM is it's a project written in Python, released by I believe it's Sylvain, one of the core committers or developers to the Cassandra project. He also works for DataStax. Essentially, it's a set of scripts to create, manage, and destroy local Cassandra clusters. It's all based on CCMlib, which is a Python library that lets you programmatically create and manage these clusters. So what I'll do now is I'll actually show you a quick demo of how to work with CCM, and you'll very quickly see just how easy it is to get up and running with Cassandra using this particular script. So let me just. John just asked a question, is CCM from Chris Beatty? It is actually from, sorry, the name escapes me straight off the top of my head. It is Sylvain Lebrezny. I'm not saying his name particularly correct. I will post it online, and it's also in the slide deck. I've also got the link to the GitHub project so you'll be able to send that or see that later on. All good. Now let me share my screen. Cool. All right. So what we'll do is we'll stop our currently running foreground version of Cassandra, and let us have a look at CCM. So CCM can be installed by either downloading the repository, so git clone, and I will post the repository link very shortly. You can also install it using pip. So pip is a Python package manager that is based upon distools. So if we have a look here, just as simple as doing that. And of course, I install it globally to my packages, so that's nice and fun. And I've already got it installed. But if you didn't, it would go off, download it, compile it, and you'd be all ready to run. So let's have a look at what CCM actually does. Let's just close that so we've got a bit of a more full screen. CCM. So let's just have a quick list. There's an awful lot of options that it presents, but the main ones that we'll be interested in are create, stop, start, and list. It also has a number of options that you can, or commands that you can run against nodes, but we'll get into that once we've created a cluster. So let's create a cluster using CCM. So the command is CCM space create. You can then also specify a number of options. So what I'll actually do is I'll show you all the options that you can currently use. So if you add -h after a subcommand with CCM, it'll give you a full list of the options. As you can see here, it's very configurable. You can do things like choosing the petitioner. You can actually tell it to use DSE, or DataStax Enterprise, instead of the open source version of Cassandra. You can do things like specify the number of nodes. You can tell it to start it automatically, to enable the binary protocol by default if you're using an older version of Cassandra. You can also tell it to enable things like remote debugging for the JVM if you're kind of working on a patch for Cassandra. You can also enable different levels of debugging, of tracing, so on and so forth. So let's create a cluster. Let's call it webinar. So the options that I'm listing here, so CCM create, that tells us to create a cluster. I'm telling it to enable vnodes, and -n says we want three nodes created. -v lets us specify the version of Cassandra. In this case, I'm asking for 2.1.7, and the name of the cluster is going to be called webinar. This name will also flow through to the cluster's name as specified within the Cassandra YAML file. So let's create that. Alrighty, so that went and created that pretty quickly. In the background, what it's actually doing is it is downloading a version of Cassandra. It's actually downloading a tarball that contains all the sources, and it will compile it. What I've actually done is before this I've previously run a version of Cassandra 2.1.7 using CCM, so it's already done that in the background. But if I was to do it with an earlier version, let's say we wanted to kind of test 2.1.2, maybe we've got an old cluster and want to test some bugs or something that's going on there, you'll see that it'll start to download the source from the Apache archive, and once it's done that, it'll start to compile it. So just on that note, I won't let it go through the whole way, as it's a little bit unnecessary. I'm sure you've all you guys and girls have seen something download before, but keep in mind that in order for you to work with CCM, you will need a JDK installed, so the Java development kit, and you'll also need Maven and Ant installed as well. So there's some Java compile tools, and that's because CCM will build Cassandra in the background. So if we then run CCM list, what that'll show is it'll show a list of clusters that we've previously created with CCM, and it'll show what's called the active one. So we can see here we've got webinar, and then we've got a few other clusters that have been listed here. So this is really cool. What it actually lets you do is it lets you create different clusters with different number of different sizes of nodes, different versions, and it lets you very easily switch between different ones. So I believe if we go CCM list and CCM switch, and we'll go to demo cluster, CCM list, it now shows the demo cluster as the active one. Cool, so let's jump back. The other thing to keep in mind with CCM is when you are running it on Mac OS is it requires you to manually create aliases on the loopback address. So the reason why it does that is for each node that it creates, or each Cassandra node that it creates, it needs to have some address that it can bind to locally on the machine that is unique. And so what it actually does is it binds to the loopback address. And so you need to create unique aliases so they can all, the process can all talk to each other, but they have separate addresses. So if we have a look at my IF config, what you'll see here is that my loopback address, or my loopback adapter, has a number of different aliases bound to it. So what I've done is I've got 127.0.0.1, which is, that's kind of always there, but I've then created 2 and 3. And then for some other exercises that we'll go through a little bit later on, we've got .1, .2, all the way through down through to .6. With Mac OS, you will need to create these manually. Unfortunately, CCM doesn't do that for you. So the way that you actually do that is you run this command here. So sudo ifconfig, the adapter, the identifier, then alias, the address, and then up. You can run this again and again, even if you've already created the address. Cool, all right, so let's actually start this cluster. So it's very simple. You just make sure you're on the right one. You then go CCM start. Now, it'll take a little while to start up. You might see a few errors pop up right there. That's because I've done some funky stuff with my Java class path with some different versions, but that doesn't have much of a material impact on this demo. So if we go to CCM status, it'll then show currently what's going on. So we've got node 1, 2, and 3. They're all listed as up. If we then have a look at what's running in our background, we can see that there are 3 Cassandra processes listed here. Apologies for the formatting. That's just one of the joys of when you're using grep. Cool, so what can we do with CCM to these actual nodes? So we can actually then start to run commands against it that you would run with node tool. The way you do that is you choose the particular node that you want to run the command against. So CCM node 1, and let's do status. There we go. So that gives us a view that we're probably a little bit familiar with, and it shows us the 3 nodes that we're working with. We can then jump into CQL shell. There we go. We're ready to go. We can also even do things like apply a schema to it. So I've got a few schemas here. Let's go basic CQL. Let's load some data into that. If I can type properly. There we go. So as you can see here, CCM has actually made what we've previously done with the tarball install a lot quicker and a lot simpler to manage. What actually happens under the hood? So CCM creates a directory in your home there called .ccm, and that contains all the directories that represent your current the clusters that you've created. The file current, it's just a text document with the name of the currently active cluster. So let's jump into one of these directories and actually see what's going on under the hood. So here we have 3 separate directories for the 3 nodes that were created, and we have a configuration file. Here we see some configuration options that apply to the cluster as a whole, so like number of tokens, the native transport, the install directory, the number of nodes, which nodes we're going to use as seeds, so on and so forth. This cluster configuration gets applied to the nodes as a whole. So let's jump into node 1. So node 1 has a few directories. It has the directories such as commit logs, data logs, and the save caches. As you remember from the tarball example, we had to manually configure these and kind of manage them ourselves. Luckily, CCM does that for us as well. It also manages the process, so it writes the PID file. If we have a look at the conf directory, we'll see it's filled with the normal Cassandra configuration files. These are generated from cluster.conf as well as the node.conf as well. So if we have a look at that before I jump into that, we'll see that there's then some node-specific configuration options. So here it sets the interfaces that it binds to, the name, whether it's going to be remotely debugged, so on and so forth. So that's how it kind of manages it all, and there's a couple of scripts, so CCM is the script that kind of manages that all for us, which is really helpful. But where does it actually store the different versions of Cassandra? Well, it stores those in the repository folder. So here we see the different versions that it has. These are the different versions that I've actually used in the past. We've got some 2.0 branches, some 2.1 branches. If we jump into 2.1.7, we will see that it looks very similar to what you would get from downloading the source code and building it yourself. Cool. So that about covers the, I guess, the very basic overview of CCM. Let's jump back to our slides. Yes, you can define the directories where Cassandra stores the information or where CCM stores it. I believe that's a configuration, a command line flag that you can pass. You can tell it to store it in a different directory if you don't want it sitting in the default, which is your home directory, definitely. Cool. So now that we've kind of got a way of working with Cassandra in a very easy way locally, how about actually integrating this into some tests? So one of the projects that we like to use is called Cassandra Unit, and what it does is Cassandra Unit is a set of, I guess, some Java classes that kind of wrap around an embedded version of Cassandra, and it provides some kind of very useful helper classes that let you load schemas into Cassandra, lets you run it within your test harness, and it fits very nicely into the JUnit ecosystem. The other benefit of it is it's it's quite portable, so it makes, and because it's all run within your test harness, so if you're using JUnit, you don't have any external dependencies on that. It makes it very portable and very easy to integrate that into any CI tools or build servers that you might have. So what I'll do is we're going to have a quick demo of Cassandra Unit, and then I'll get into some other test classes that will be helpful and more useful in languages other than Cassandra. Oh, sorry, other than Java. So let me just bring up my IntelliJ window. All right, so what you can see here is, so I run IntelliJ. The project that I have up here is a project called Apache Zeppelin. Apache Zeppelin is a web notebook and query application for Apache Spark, and what I've done is I've actually written some functionality that makes it very easy to integrate with Cassandra and to run SQL queries against Cassandra. I then went to submit the patch to the upstream project, and they said, oh, that looks all great, but of course you need some tests. So what do? I need to write some tests. If we have a look here, what I've done is I've created a class called Cassandra Spark SQL Interpreter Test, and I've included the Cassandra Unit testing library. Let's jump to our POM file and see how we define that. So here we are. Now, I won't go too much into detail because I know that not everyone is a Java developer, and even Java developers don't particularly enjoy staring at XML all day. But it's very simple. We declare Cassandra Unit, the version that we want, what scope we want it in. I like to exclude dependencies that are being used elsewhere in the project, so particularly the DataStax core driver, and also if you exclude Cassandra.all and then define it outside of the Cassandra Unit dependency, it actually lets you control which version of Cassandra you run the tests against, because the Cassandra Unit, it comes with, it includes a version of Cassandra with each one of its releases, but as a dependency, but that might not necessarily be the one that you're using. So if we jump back to our test class here, what you'll notice is I've defined a Cassandra CQL unit. Now that is a class provided by Cassandra Unit, and it has a little bit of magic in the background that lets me load a schema file against a particular key space. But when JUnit calls the various rules that are associated with this particular test class, it'll actually start an embedded Cassandra server in the background. And you can see in these comments here, it's essentially doing an embedded Cassandra server helper, and it's starting an embedded version of Cassandra. I could actually have these calls in my setup class, and I could manually load it myself, but I kind of want it to do it all automatically for me. So let's actually see what happens here. I am going to just change the logging level here so we can actually see Cassandra starting in the background. And I am going to run these tests. Let's just put a breakpoint here. Now, like all good demos, let's make sure it works. I ran this the other night and it did, and I haven't changed anything. So we'll see what happens. We'll pray to the demo gods. Cool, alrighty. So let's run that. Let me just see whether it actually did decide to log.
don't think it did, but that's all right. I won't jump into why it's not doing anything. I'll hit the go button. What we should be able to see here is the Spark output log, and we can see here that it's actually querying Cassandra. The test is passed. It's queried the Spark test key space, which we've defined in this cassandra.cql file here. So it creates a table called test and inserts some kind of dummy data. And here we've got our assert statements. We make sure that the result is actually true, and then it equals a couple of things. The SQL will look a little bit different here as this is Spark SQL rather than CQL, but it is bringing up a Cassandra instance in the background to query it using Spark. Cool. So we will stop sharing that. We'll go back to the slides. And we'll jump through this. So, yes. So what I was actually looking to talk about before my slides got a little bit jumbled out of order there is, obviously you can also use your various testing frameworks against a manually deployed version of Cassandra. So either using the tarball install, but that will require you to do things like calling, truncate, drop key spaces, and then separately set up Cassandra, using your CI and integration tools, or however your test framework does it. And that can be a little bit painful. What we really want is, Cassandra units are all well and good, but it's very specific to Java. It also, doesn't allow you to do things like testing whether, your application works when you're using different consistency levels, how it reacts when you've got one node down, how it works, if you in a multi-data center environment, all that kind of thing. So it's a very easy and flexible framework to use, and I'm a big fan of it. But it is very Java centric, and really it is only kind of good for some basic unit tests rather than necessarily some integration tests. So when it comes to testing and automating our tests, we'd actually really like to use CCM because it does a lot of the work of setting up complicated or what I'd call more realistic Cassandra topologies, and then being able to use that for our tests. On top of that, we also want some way of using it in a way that's, I guess, flexible or portable between different languages. So as CCM is also used for Cassandra's distributed tests, it's also actually used within for testing Cassandra data stacks as Cassandra drivers. So that means that there's Java bindings for it, Ruby bindings, and a Node.js, and they've created some bridge classes that you guys can actually use. So what I'll quickly do is I'll actually show you the data stacks Java driver running CCM. So as you're aware, CCM is a Python library. It does kind of require some interfacing, from whatever language you're using. So let's just jump back to IntelliJ. Alrighty, so hopefully it's now showing the correct window. It's now showing the Cassandra Java driver. And we should be able to see a test called consistency test. What this is it's a test to see how the driver handles various levels of consistency. We've also got some other tests here. We've got an authentication test and a stress test. So what we'll do is we'll first have a look at the authentication test, as this one's a little bit quicker, and I am aware that we are running out of a little bit of time, and I want to leave some time for questions. So as we see here, what the test is doing is it's creating this class called CCM Bridge. CCM Bridge is the class within the driver that they use to interact with CCM, the Python project. You can see some things here. It sets environment properties before it calls it. It's got some code to kind of manage executing the process, all that kind of fun stuff. So let's give it a quick go. Hit the debug button. Wait for it to, cool. All right, so here it's going to call CCM bridge create. So this is very similar to what we were doing on the command line, calling CCM space create, we're defining it. CCM create by the bridge, it has a number of default operations. Or if you actually have a look below, what it'll do is it'll make some subsequent calls to CCM to, once it's created that cluster, you can actually tell it to add nodes by calling like populate. You can tell it to update its configuration, to start it, so on and so forth. So if we jump through, it's going to populate CCM, and it's going to update the configuration to use the password authenticator, add some options, and it's also going to start it. And let's hit go. There we go. So as you can see, all these tests are fairly short. You can see in my output window, you can see some of the output from the Cassandra driver. It's detected a new host, Cassandra host 127.0.1.1. And so that's the node that CCM created, and it's managed to connect with it properly. During these tests, if you actually have, if we actually have a look at CCM on our command line, it won't actually show up, because what the test class and the bridge class has done is it's actually created the CCM cluster in a different directory. And as one of the other questions was, can we change the location of the data directory in the commit logs? You can also change the entire location of CCM itself. Can you guys still hear me? I'm going to keep, okay, cool. Yeah, so if you're working with Java, okay, I will backtrack 15 seconds. So yeah, so how do we integrate with Cassandra in our test frameworks? Honestly, I would say that CCM and Cassandra Unit are the best for this. Cassandra Unit, while it does require no additional config, it's obviously Java first. And so, it's only kind of useful for Java. I'm not 100% certain whether there are other frameworks out there that are very similar to Cassandra Unit, so for like Ruby or Python or those kind of languages. But CCM kind of like fills that void. It does require Python to be installed and the CCM to be installed, but most kind of continuous integration or testing frameworks do provide mechanisms for ensuring dependencies are kind of met. Then you can use whatever language you're using. You can use the CCM bridge that's provided in the various driver classes, the various driver packages to manage that, and you'll be able to set up, tear down, and kind of modify the cluster as you need to during your tests. So dev tools. The basics will certainly take you a long way. The main ones that I use is DataStax Dev Center. It's essentially kind of, it's like a stripped down version of Eclipse that has some great syntax highlighting for CQL, and it also lets you manage connections and querying the cluster. I do have a demo for that. I will, that's not supposed to be Cassandra unit, it's supposed to be Dev Center. I'll actually skip that one. What I really want to show you is actually the two main tools that I tend to use a lot, which is CQL Shell and the Cassandra CLI. Now, the reason why I quite like to use Cassandra CLI as well as CQL Shell is it provides a lot of insight to what Cassandra is actually doing under the hood. So I'll quickly jump into my shell again. Just wait for that to share it. Cool. All right, so let's go back to the webinar directory. And I am going to jump to one of our tarballs, because this will actually just make it a little bit easier for me to show you guys what's going on under the hood. Run bin Cassandra in full screen. And of course, because we're running lots of different versions of Cassandra, we need to make sure that we have actually shut down the other Cassandra processes that we have been running. Occasionally, CTM stop can take some time, but not today. So let's try that again. Cool. I will now start a new window. CQL Shell. Now let's have a look at some data that we previously, I've got an absolutely fresh cluster. So let's import some data files, and then we'll go webinar schemas, and we will go test. Cool. Alrighty, so what we've done is we have imported some data into Cassandra. I'll quickly show you what the schema looks like. So we have here a table called foo.bar, and it has name, text, ID, and value. Now, one of the things that a lot of people struggle with Cassandra when they first get into it is the data model. So what I find is it's actually usually very helpful for me in order to develop, I guess, a conceptual idea of what's going on under the hood, is actually to get in and play with the data myself and actually have a look at what it looks like kind of under the hood. So what we've done is we've created a table called foo.bar and another table on top of that as well. And in CQL, what we can see is we've got list of names, IDs, values, and it's presented to us in a number of rows. But based on that schema that we actually previously created here, which is here, we specified our primary keys being name and ID. So it's then returned the results to us in about 15 rows. But when we actually talk about a row in Cassandra, sometimes it gets a little bit conflated with the idea of a partition, particularly when you look at the way that Cassandra is used to represent partitions, and particularly when you talk about it in terms of the ways that the thrift world views it. So let's actually have a look at what this looks like using Cassandra CLI. There we go. Use foo. We'll go list. So now things actually look a little bit different. So we've got two rows here, one called Dave and one called Ben. This is actually quite different to what CQL Shell is showing us, whereas it had 15 rows with the names Dave and Ben, but within the CLI, it actually shows very clearly Cassandra's wide column format. It shows name as the column name and then the value here. What I've done is I've created this with compact storage, so it shows it a little bit more succinctly. I won't get into too much between the difference of compact storage versus other table definitions, but what you can see here is that by using CQL shell when you're developing your schema and then using Cassandra-CLIs, you can actually see the difference between what you're creating from a conceptual or a logical point of view and how Cassandra actually writes it to disk in that wide column format. So when you're kind of reasoning and thinking about your data model, you can actually see how your partition key and your clustering key will impact your data model. And you know, sometimes I find that the Cassandra-CLI tool is a little bit easier to see how it's being represented under the hood. All right, let me jump back to the slides. So that about wraps up. Yes, so CLI is being removed in 2.2. I don't know what a better option is. It is being deprecated. I believe it's a little bit, so the decision to deprecate Cassandra-CLI was made with the refactor of the underlying storage engine, but that's been pushed back to 3.0. So I'm not too sure whether they are actually going to take out Cassandra-CLI in 2.2, given that they've had to push back the storage engine changes in 3.0. I would like to still see it kept in at least until 3.0, just because it makes sense to work with the the change in the storage engine. But yes, that is a very good question. But I guess we'll have to see how that release process goes. Cool. All right. Well, thanks for bearing with me on this, and apologies I kind of had to rush through it in the end, but I was very keen on making sure we stuck to the hour and were able to get some questions.